Ahmed has a thriving shawarma restaurant. He doesn't care about GDPR rules and collects a lot of data of his customers. But now he doesn't know what exactly to do with it. This is where we come to help him with something called data mining. Now, data mining is all about finding nuggets of golden insights in mountains of data. And we will cover in this short introductory video, first of all, what and why we need data mining. Then after that, the entire process. Then we will go over the differences between database operations, machine learning, and data mining. And then lastly, we will look at some quick applications of data mining. Now let's start with what and why. Now, globally in this year, 2025, it has been projected that we produced 175 zettabytes of data. Just for you to get this into a bit of perspective, that's about 1.75 trillion GTA 5 downloads in 1 year. Now, anybody who has ever downloaded GTA 5 knows how long it really takes, especially on bad Wi-Fi. But just to put that also into perspective, that's 55,000 GTA 5 downloads every single second of this year. So meaning in this entire year, we collected as much data, like in the world in general, as if we would have downloaded 55,000 GTA 5s every second. Also, Cloudflare reports that globally, the internet traffic grew by 19% in this year. And Cisco reported back in 2023 that there were 5.3 billion internet users. I actually thought that we would have like almost everybody on the internet by now in the world. But yeah, crazy. 5.3 billion is still a lot of users on the internet. With that, of course, we have a bunch of data that needs to be mined to get insights. So what exactly is this then all about? Imagine you have a lot of data points. So these, blue and orange circles are supposed to be data points. And we basically want to get knowledge out of it. This is the difference between just having information and actually having knowledge. So for instance, information would be, you have a list of customers and what they bought. And the knowledge would be exactly what types of customers would buy what things together. And in this, we basically look for knowledge that is valid, novel, useful, and understandable. These are basically these golden nuggets of data that we want. Because if it's, valid and novel, meaning something new, but it's not useful at all, then we can't really commercialize it, meaning there's no money in it. And then also, if it's basically useful, but it's not understandable, then we can't actually take this information and do something with it useful. So let's get Ahmed back here for a second. Let's say this is part of his user database of his customers that bought specific items together. Now, as you can see here, 2 of his customers bought shawarma and fries together. This gives you maybe an insight, or this might give Ahmed an insight, that he can actually make a bundle maybe out of this and maybe make some money too. So now he knows that a lot of customers like the combination of shawarma and fries, for instance. So what is this process actually about? Basically, you can think of it as 3 steps. The first one I have coined data preparation, just as a umbrella term for all of these data tasks like data cleaning, integration, selection, and transformation. Then we do the actual data mining itself, which we will get to what this is. And then lastly, we'll go over the evaluation and also, if you want, to go over some presentation styles too. So let's start with data preparation. Imagine you have this type of database. Let's say you scrape this from, like a used car websites, these websites where you can buy used cars. And you see here that there are some actually data points which aren't really cleaned yet or it's not really nice. So you have here, for instance, that the price of a car is just $10, which might be a bit off, and it's definitely going to hurt, let's say, an average, if you take the average. And then you have, for instance, here the last one, where probably somebody was joking, and put as kilometers minus 10 kilometers, and then as a price, $1 bajillion, for instance, right? So clearly this is a bad data point that you don't want to, poison your models with, or you don't want it to affect your evaluation. So we would then actually clean these out. You can also do things like data integration where you maybe add additional data. Let's say, for instance, you also have a column which has the precise location of the car, and then you basically augment it or integrate with that also, let's say, the GDP of the country that it is in. Therefore, you can basically compare the car with the GDP of the country that you're in, for instance. That would be data integration. You can also do data selection. So not every data point might be really useful. Let's say you have here the name of the person who actually sold the car. Now, that might not be fully useful depending on what exactly you want to get out of this data mining procedure. And then lastly, also data transformation, where it could be, let's say, instead of kilometers, we would have miles, but we want kilometers instead. Therefore, we would transform the data into basically a different format. Now, the next step would be data mining, and we can think of two main tasks, predictive and descriptive tasks. With these, we would then decide on what machine learning models we would take to basically describe the data better. This could be, for instance, when you're trying to predict something like a decision tree or KNN. And then if you're trying to describe the data, meaning you want to see, the clusters in it or all of these things, you can use clustering and dimensionality reduction, like PCA and similar. Then for the evaluation, let's make this a bit smaller. In the evaluation, be trying to validate our findings. Let's say, again, we have the fact, the knowledge that shawarma and fries are bought with each other a lot. We could, for instance, then go to an expert. Let's say the expert is the person who basically is at the counter selling the shawarma. And you ask them, like, hey, can this be true? Do you actually have a gut feeling that you think that most sales are indeed shawarma and fries? That would be one way to validate your findings through experts. Another way would be through data. So you basically test your hypothesis then with the data again itself. Lastly, you can also do something like an A/B test where you basically take your findings and then try to have two subgroups of people. And one of them you give your good model, and the other one you don't give a model, just to see if your findings are actually valid, Let's say you have the finding that shawarma and fries fit together well. And then in Ahmed's online, ordering store, you basically give one group of users, a random subset of users, the chance to get shawarma and fries, and the other one's not. And then you try to compare the findings from that if, does shawarma and fries bundle actually give you more money or not? Then we come to the differences between database operations, machine learning, and data mining itself. Now, with database operations, that's just how I coined it right now. Basically, what I mean is when you do like these SQL queries on, these transactional and analytical databases, just to get some quick insights, And this is like I wrote here, some quick analytics in a database itself. For instance, we want to get the sum of all sales today or the number of all fries sold, for instance. Next, machine learning is all about minimizing a loss function. Now, machine learning itself is very statistical and mathematical, and it's all basically just about getting a single model as good as possible. You can think of it as LLMs or like generative adversarial networks or all these types of models which we try to optimize. And the procedure to do that is partially different than in data mining. Then, of course, we have data mining. And this is, like we said before, it's all about finding deeper insights in data itself. So this is, for instance, what do customers usually buy together? Or what should I recommend to X user? Lastly, I want to talk about some applications. Now, for the applications, we have the business, web mining, quality control, life sciences, and lastly, game playing. And I mean, there are many more other than that. For business, you can think of them as like market basket analysis, recommender systems, and fraud detection. For web mining, you can think of categorizing web pages or spam detectors in emails. And then you also have quality control. And then you can also look into this into life sciences itself, like biology, chemistry, and all of that, and medicine too. And then lastly, also in game planning, we can actually use data mining to try to identify winning patterns. But yeah, that is it. Thank you very much for listening. And I hope that you learned something. And the sources of this was the lecture series on computational data analytics from Professor Johannes Phil of the JKU.